Hi everyone. So here I can continue on the lesson topic 31. So successive integration. When we continue to do integration and we do just, for example, I receive second derivative and I find the first and original function. Also, I can have more information in the question and I can find C, which is the constant of integral. Okay, so this is just part of this lesson. So look at this question. Usually in the final exam you have one of these questions. So find the function whose derivative is that. So you have to find y, that when you know y, dy is, dy over dx is 2x, or y prime is 2x. Okay, so if you want to just follow some of books or maybe some teachers, you can do this: dy equal 2x dx, and therefore y is integral 2x dx, right, which is x squared plus c. Or simply you can say it's the same thing. Okay, just I would say, sorry about that, just I would say y prime equal 2x, and therefore y is integral 2x dx, which means it's x squared plus c, right? But it says find the function. Let me see. Yes, it says find the function which has this derivative, and it goes through that. So I found the function and the derivative is 2x. Yes, if I do the derivative. But I have more information. So in this case, I can find c. How do I find c? Agreement, I know this is x and this is y. So I do 9 equal 2 squared plus c. And c is 9 minus 4, which is 5. So here I do not have infinity number of answers because I have a value for c. So my answer is x squared plus c. I can check my answer. I can see y prime is 2x. Perfect. And also I can see 9 is 2 squared plus 5. Oh, sorry, I have to use 5 here. Okay. So instead of infinity number of answers, I just have one answer, which is that. Okay. Now I can continue to go to the next lesson. So successive integration, as I said, for example, I give you second derivative and I want you to find the original function. Okay, so in this case, I want you to read the question carefully. Find the equation that you have second derivative. Oh, okay, here I have second derivative. Okay, second derivative is 4x minus 2. And tangent slope is 1 at that point. The meaning of this part, tangent is 1 at this point. These are all together. The meaning is y prime at 1 is 2. I'm so sorry. Y prime at 2 is 1. Because look at this, it says at this point, so this is that point, x. You always use that point for x. Okay, and also it says tangent slope. So tangent slope is the first derivative. Okay, so I have another piece of information which is that, and I have another piece of information which is that. How do I know? I check my point here. When I check my point here, I see this means y at 2 is 9 because that's y values. This is a point on the function. Okay, so I want to find y here, but I have second derivative. In this case, I have to do integral twice. Okay, so I have y double prime equal 4x, which is the second derivative, 4x minus 2, and then I have y prime equal integral 4x minus 2 dx, which is 2x squared, oops, sorry, 2x squared minus 2x plus c. Okay, can I find c here? Yes, I know c is, I know first derivative is 1 when I plug 2. So I have 2 squared minus 2 times 2 plus c, and then c is 1 minus 8 plus 4, which is minus 3, right? So if I have, yes, 8 minus 4 is 5, and 8 minus 4 is 4, and 4 minus 3 is 1. Okay, so that's the answer for y prime. But remember, here you just find y prime because you did one integration. Okay, so you start from second derivative and you go to the first derivative with integral, and you find c here. How you find c? You use this information. Okay, because you know the first derivative at 2 is 1. Okay, so now you can continue. So c y prime is 2x squared minus 2x minus 3, and y is, so I find y, which is integral of 2x squared minus 2x minus 3 dx. That's wonderful. So here y is 2 over 3x cubed minus x squared minus 3x plus c. I don't need to say C1, C2. I just have to keep in my mind that these C are not the same. I have C for every integration. Okay, and that means constant. But sometimes a student, they like to use C1, C2, or CD. Okay, so how do I find the second C? I have to check this point. C at 2 is 9. Okay, so I put 9 here. I put 2 over 3 times 8 minus 4 minus 6. Am I right? Yes, plus c, and then I can find this c. So I have 9 minus 16 divided by 3 minus 10, so it's plus 10. And am I right here? Yes, it's 19. 19 minus 16 over 3, which is, let me check my calculator here. So I think 57 times, yeah, 57 minus 16, which is 41. So it's 41 divided by 3. This is the second c. Okay, so what is my function? What is my answer? So my answer is y equal 2 over 3 x cubed minus x squared minus 3 cx, sorry, plus 41 divided by 3. Okay, so when you substitute 2 here, you can see the result must be 9. Okay, when you substitute, see it has, so I can check 2 over 3, so it's 2 over 3 times 8, and so minus that, minus this, plus this. Yes, it's correct. So I check that. I check y at 2 is 9, and y prime at 2. See, y prime here is, this is y prime here. That's y prime. So I can check y prime at 2. Y prime at 2 is 8 minus 4 minus 3, which is 1. Yes. And also I can see the second derivative is 4x minus 2. So if I find the first derivative is 2x squared minus 2x minus 3, and then I have 4x minus 2. See, everything is working. Okay, so here when I say successive integration, means I continue to do integral because I have second derivative. So from second derivative, first I go to first derivative, and then I go to the original function. Okay, so Now these are practice questions here. See, we are done for the lesson. Very easy. So now I can find the answer. So it says solve the differential equation. If you go to university and you do science or engineering there, you have a course called differential. Um, the course is differential equations, something like that. And then for one semester, you will see method to find the original function when you receive the derivative. So you will see many methods for different kind, and so it's very nice. Okay, that's why. So there you see these questions like solve differential equation. So when I say solve differential equation, it's very new to you, because here we say just do integral or find the original function and this kind. But if you do differential equation course, you see that. So the meaning is just find original functions, means you see the derivative and you want the original function. That's it. So that's just the same. Okay, so means here I am looking for v. Oh, okay, I have derivative of v. Okay, so I do integral 6t cubed minus 3t power minus 2 dt. Look at here, I have t here. Okay, remember, don't write dx. If you do dx and you have t there, it doesn't work. You just have to, if okay, see here, if I have dx here and I have t here, then I have to say t is a constant, because t is not dx. It doesn't have anything to do with dx. Okay, so it has to be the same here. So v here is integral, and you do 6 divided by 4t power 4, because it's just a power function, minus 3 divided by so t power, if I have minus 2 plus 1, minus 1, and divided by minus 1, okay, plus c. So I have 3 over 2 t power 4 minus plus 3 over t plus c. Okay, and just check your work to see if it is really working. See, if I find v prime here, I see 12 divided by 2 is 6. 12 divided by 2 t power 3 plus t power that's minus, so it's minus 3 t power minus 2. Yes, and when I check, I see I have the same thing here. Okay, yes, I have the same thing here. Okay, so I can check my answer. So here, when I say solve differential equation, means I gave you one derivative, and I want you to give me the original function. So if you do differential equation course, you will see this question all the time. Okay, so how about here? Here I have question 2 and 3, and okay, just the application, which I guess for the application, I'm not sure if I continue tonight. Okay, so yes. Okay, so look at this. You have derivative. Okay, see, you have derivative. Derivative equal 2x plus 1. You have y at 1 equals 7. Okay, it says what is y at 3. I have to find y first. Okay, so y is integral 2x plus 1 dx. I told you this and this come together. I cannot separate them. Okay, so it is x squared plus x plus c. Then I have 7 equal 1 squared plus 1 plus c. C is 5. Okay, now I can sub there. So I have y equal x squared plus x plus 5. And then I want to find y at 3. So I say y at 3 is 9, because it's 3 squared, plus 3, which is 12, plus 5, which is 17. Okay, this is what I'm looking for. Okay, see here, it's giving you y at one point and asking y another point, but you have the derivative, so you have to first find the function, so you have to do the integral first. Okay, so here when I just check, my function here. So if I put 3 here, so I see 9 plus 3, 12 plus, okay, that's 17 here. And if I find the derivative, it's 2x plus 1. And if I find that 1, I have 7 as well. Okay, so perfect. So this is what I need here. How about this one? So it says find the equation of the curve that has second derivative. See here, I give you second derivative. So you have second derivative equal that. Yes, you have a slope of tangent line at this point. So y at 1, look at this, 1, y prime at 1, because it says a slope of tangent line is -6, and y at 1 is 0. Okay, so first I go from this to y prime, integral 12x power da dx, which is 12x power -2 divided by -2 plus c. Simplify. So it's -6 over x. I can keep it up because I need to continue to use the formula. Okay, so I said the derivative at 1 is -6. So for that, I say, okay, so 1, sorry, -6 is -6 times 1 power -2 plus c. And yes, I see c is 0. Okay, and then I can continue. Okay, so I can continue to y. So y is what is y here? Y is integral of y prime, which is, let me see. Okay, so let me make it easy for you. So I do and easy for myself. Okay, so what's going on here? It doesn't let me to remove it. Okay, so y prime at so y prime, just original y prime. What is y prime original? Okay, y prime is -6 x power -2 and plus 0. Okay, so y is integral of that dx, which is -6 x power -1 divided by -1 plus c, which is y equals 6 over x plus c. And then I want that the other c I need, so I know y at 1 is 0. So y 0 equals 6 plus c, and c is -6. Okay, so look at this. My function is y equal 6x minus 6, sorry, 6 over x minus 6, and then I find y prime. So this is 6x power -6 this, and then I find y prime. Y prime is -6x power -2. Makes sense? Yes. And then I find second derivative. Okay, the second derivative is 12x power -3. That makes sense. Yes, it is working. Then I say, okay, what is the function at 0? Sorry, at 1. When I put 1 there, I see yes. When I put 1 here, I see 6 minus 6 is 0. It's working. When I put for y prime, when I put when I put 1 there again for y prime, the answer is -6. And it's still working. So I see, when I check, I see yes, this is working, and I see y at 1 is 0, and then I say y prime at 1 is -6, and working, all of them working. So this is the answer. Okay. Okay, here we have application of motion, and so here we have the application. So here, for example, I can give you acceleration, and I can ask you for velocity. I can give you velocity, and I can ask for displacement, and you can do it by integration. So if I give you this, one, and I want you to find velocity, you just do the derivative. This is question in the test number 4. If I give you velocity and I want you to find acceleration, you do derivative. But how about opposite? Opposite, you do integral. Okay, so you can do that here. So, okay, what do I have here? So a particle moves with a constant acceleration. Means acceleration doesn't change, just constant. So A, or just, yeah, acceleration is 1.22 meter over second squared. Okay. Initial velocity is this, means velocity at 0 is 1.80. This means C. This is your C, or this gives information for C. Okay. So initial displacement is S at 0 is 0.600 meter. This is also C for the second integral. Okay. So I have the acceleration. Okay, what is velocity? Integral of acceleration, dt. Remember, because it's based on time. Okay, so what is v then? V is 1.22 t plus c. What is c? V at 0. Okay, so v at 0, which is 1.80, is 1.22 times 0 plus c. Oh, perfect. So this is 1.80 then. Okay, so then what is S? Okay, so S is integral of 1.22 t plus 1.80 dt. Yes. Okay, so what is 1.22 divided by 2? My God. 0.61. Okay, so it's 0.61 t squared plus 1.80 t plus c. This is another c. Okay, and c here is this one. Okay, so this c is that, and this c is here. Okay, so you have s t is 0.61, oops, 0.61 t squared plus 1.80 t plus 0.600. Am I right? Yeah, meter. Okay, so this is the function, right? You can do the derivative and see, yes, it's working for the first derivative, and the first derivative gives you v, and the second derivative gives you the acceleration. So now you can go backward. You can have acceleration and go to v by integral, and from v you go to displacement by integral. Okay, so let me see here. A body moves with the constant acceleration. It has initial velocity and initial displacement. So this is exactly the same question, but different numbers. So you have acceleration 21.5 meter per per second squared. Yes. So you have v at 0, 27.6. You have s at 0, 44.3. Okay, and find the answer. Okay, so you can do it. So here I stop because this is for rotational motion, and then in this case maybe I need more energy to explain, and so I can finish here. So thank you for your time, and okay, so today, yes, it's just 31st of March, the last day of March, and I'm done here. Okay, thank you so much for your time. If you find any mistake, just let me know. I appreciate your time. Have a good night. Stay safe and bye.